Hey Code Crew, today you're going to learn how large iOS development teams work together to produce large and complex apps such as Instagram, YouTube, and Spotify. Now, how do multiple developers work together on the same code base without overwriting and destroying each other's code? And how does a developer add his or her code without accidentally destroying some functionality in the app? And finally, how do you organize and keep tidy thousands of lines of code written by multiple developers? Well, today I'm going to answer those questions and more, so stay tuned. Hey there, I'm Chris and welcome to Code with Chris, where we're going to teach you how to become a developer through building iOS apps. Now, as a single indie iOS developer, you can do some pretty cool things, and there are a lot of successful indie apps in the App Store. But on the other hand, as a single developer, you are limited by the scope and scale of the apps that you can build. Because at the end of the day, we're all limited by the fact that we have 24 hours in a day. A lot of the mass audience, large-scale apps in the App Store are built by teams of people, testers, developers, designers, product managers, you name it. Now, how do all of these people work together to produce a single app? Well, today we're going to look at some of the unique problems that teams face and how they overcome them. But before we dive in, I just want to give a shout out to CircleCI.com, who is the sponsor of this video. They enable large teams to work together efficiently to produce awesome apps through their continuous integration and delivery services. Now, these two processes are something that is very important for large teams to collaborate through, and we're going to touch upon them later on. But for now, let's take a look at large team problem number one. So how do multiple developers work together on the same Xcode project? The answer is source control, and in this case, source refers to source code. Now, there are many different source control management systems out there, but one of the most popular ones is Git. And GitHub is a popular choice for Git repositories in the cloud. Now, here's a quick rundown of how Git works. The Git repository, or Git repo for short, contains the master copy of the code. The repo also keeps track of versioning of the code. Let's say it's version 1 right now. When you want to work on the project, you check out a copy of the code. It's kind of like checking out a library book. In this case, you've made a local copy of the code. This is also known as pulling the code. Another developer, let's call her developer B, can also check out the code and make a local copy on their machine. You're both working on your local copy of the project, and maybe you finish your work first. Let's say you had to fix a bug in the project and you nailed it. The next step is for you to commit your code back to the master repo. You can and should attach a message to say what you changed and why you changed it. When you send your changes back to the repo, the message you wrote will be attached to that change. Now, this is known as committing or pushing or checking in your code. Different people will like to use different terminology. Now, let's say developer B has finished her change and she's ready to check in her changes back into the repo as well. But there's a problem because after you checked in your code to the repo, you've essentially changed the master copy of the code, and now it's out of sync with her local copy that she checked out earlier. Now, developer B doesn't have any of the new code that you checked in, so if she were to blindly check in her version back to the repo, she would essentially be overwriting your code. Luckily, source control would detect that the master copy has changed since developer B last checked out the code, so it's not going to let her commit her code. Developer B has to do a merge, which involves getting the latest copy of the code from the repo, merging it with her local copy, fixing any errors that may arise from your code conflicting with her code, and then after resolving any issues, to commit the merged code back to the repo. If you and developer B happen to work on the same file and same lines of code, then there might be a conflict in which developer B needs to manually decide how to merge your code with hers. Now, as you can see, this merge process can sometimes get pretty complicated, and you're going to have to be careful not to overwrite anyone else's changes when you merge their changes with yours. Now imagine a team of 10, 20, or 30 developers all checking out and committing code. A source control management system makes sure that everyone can work on the same code base without accidentally overwriting each other's changes. But to have so many people writing code also means that it's hard for one person to know the whole project inside and out, and as a result, any one developer might accidentally write code that introduces bugs into the app. And this brings us to large team problem number 2. When a developer commits his or her code to the master repo, how do they make sure that something isn't broken? Large projects can be thousands of lines of code, so it's only natural that bugs can crop up unintentionally. And this is where unit testing comes in. Unit testing is a process by which you write code to test your other code. Here's how it works. You break down the code in your app into units that make sense. Let's say you have a chunk of code that creates user accounts. Now, typically this code gets run after the user enters in their info from a form in the app. But since you want a way to test this chunk of code at will, you'll write a test case. This test case, called a unit test, will attempt to create an account with some dummy data. Now you can run this unit test, and if it suddenly fails, then you know that the unit of code that creates accounts is not working. Now imagine you write these unit tests for every chunk of code that does something in your project. You'll end up having a suite of these test cases that you can run anytime you want to see if something in your project isn't working. Now it won't catch every single bug, but it acts like a baseline, and it's your first line of defense. And once you write all your test cases and it's all set up, you'll have an easy way to test that baseline. Now, when a developer checks in some code, you can run these unit tests as an easy way to screen if some baseline functionality has been broken as a result of that new code. Alright, so you've got source control management and unit testing as tools to help large teams work together, but here's another problem. Now, just like handwriting, every developer will naturally have a slightly different coding style. So won't a code file that is written by multiple developers be really hard to read? And this brings us to large team problem number 3. How do multiple developers maintain a consistent coding style? Well, first the team establishes a set of coding conventions or a style guide. Now this can be as detailed as saying if the opening bracket of an if statement should be on the same line as the if keyword or on the next line. And it can also say things like how many line breaks should be in between methods in a class. The more detailed you can be, the more consistent your code base will be. Now, in order to enforce these coding conventions across a large team, there are tools out there that can scan the code, and then it can tell you any lines of code which are not adhering to the style guide or the coding conventions that you set forth. These tools are commonly referred to as lint or linter tools. Now, there are a lot of free lint tools out there, and simply using one will ensure that your code base is tidy and consistent. Now, we've talked about a lot of different tools, but ultimately, who is in charge of running these tools in a team? Well, in the ideal case, each developer would A, make sure that before they check in any code into the master repo, that they pull down the latest version and they merge any changes properly. And I say properly because merging isn't always a trivial process. I mean, you're trying to merge your code with someone else's code that you didn't write, and you have to take the time to understand what they wrote, what their intentions were, and merge it with your code in a way that doesn't cause conflicts or unintended behavior. And B, before they check in their code, they should make sure that all of the unit tests still pass, just in case that the new code or the change that they wrote breaks something else. And C, before checking in their code, they should run the lint tool and fix any code that doesn't conform to the style guidelines set forth by the team. Now, even if a developer does all of this and has the best intentions, we are all still human and mistakes will happen. Code will be improperly merged, builds will break, tests will fail, and bugs will crop up. It would be a full-time job for someone to continuously monitor the code base and make sure it's in tip-top shape after each time a developer checks in code. Well, fortunately, we don't need a person to do this. And this is where something called continuous integration, or CI for short, comes in real handy. Continuous integration is a system that monitors the master repo and runs various checks and balances to ensure that the master code base is in tip-top shape. The CI process is highly configurable, and it can automatically do things like build the project to make sure it runs, run the test suite to ensure that all of the unit tests pass, run a lint tool to check for code that doesn't adhere to coding conventions, and it can even do more than that, such as send a successful build to a QA environment or deliver it to iTunes for deployment into the App Store. It can do all of these things automatically by running on a specified schedule or running whenever someone checks in code. If the CI process finds a problem, the appropriate people can be notified immediately to fix the problem. Like maybe if the build is broken after the last code check-in, or a unit test no longer passes, or maybe the newly checked in code fails the lint tests. Knowing about any issues right away is crucial, especially with a large team, because so much code is being written per day that it can quickly pile up on an issue, and it can take a long time to unravel the issue if it remains buried. A continuous integration system lets the team work confidently and stay focused on coding because developers know that the CI process will catch any mistakes as soon as they happen. Continuous integration often goes hand in hand with continuous delivery, which is a process that can automatically send builds to different environments, such as sending the build to a test environment for the QA team to test out some new features. CircleCI is one of these platforms that can do all of this and more. Now we're going to do a demo, and I'm going to show you and put into practice everything we just talked about. We're going to start a new Xcode project, and we're going to commit it to a source control management system. Now, Git is a popular choice, and it's a great one for us to use because there's tight integration for it within the Xcode IDE. However, we're going to use GitHub so we can actually store our Git repository on the cloud. Then I'm going to show you how to write a simple unit test, and I'll show you how to run it. Finally, we're going to hook up our GitHub repository to CircleCI so that every time we push code from our computer to GitHub, CircleCI is going to get the latest code from the master repo, run our unit tests, build the project, and also use SwiftLint to make sure that everything is okay. All right, so let's dive in. All right, so we're going to start our brand new Xcode project, and I'll show you how to put it on GitHub. So our first step is to create our Xcode project. So go ahead, launch Xcode. Let's create a brand new Xcode project. I'm going to choose a single view app here. And for the product name, I'm just going to call it large project because that's what we're talking about, right? Now, the important thing is to include unit tests because I want to show you guys how to write a sample one and run it. And go ahead, click next. You can save it wherever you want. I'm going to put it on my desktop. Now, what's also important is to check source control here. It's going to create a Git repository on your Mac. Don't confuse this with GitHub. This is a local Git repository. It's still source control. The only thing is that that repo is stored on your machine. Now, as a single developer, this might be fine, but you do have to think about the risk of potentially your hard drive failing, and then you'll lose your code. So it's always a good idea to put that on GitHub, and I'll show you how to do that. So go ahead and enable this for now. Click Create, and here we are. We have our sample project. The next thing we're going to do is to sign up for a GitHub account if you don't have one already. And the great thing is that private repositories are free now. It used to be that only public ones were free, so all your code would be public, but now even private repos are free as well, so you don't have to pay anything. So sign up for GitHub, go to github.com if you haven't gotten an account. If you do, then you can move on to the next step, which is hooking up Xcode with your GitHub account. And the way you do that is you go into Xcode Preferences, and you can see here I have my account hooked up. If you don't have this, go ahead, click this plus icon here and just choose GitHub from the list, and it's going to ask you for your account and password. So you want to go ahead and do that so that you can integrate Xcode with your GitHub account, and so you can push code and pull code back and forth very, very easily. So after you do that, the next thing we're going to do is to put this large project into our GitHub account. And the way you can do that is you can go here. This is where you can look at all of your source control navigator. This is what it's called. And you can actually go under branches. If you're not aware, you can have different branches or versions of your source code, and you can choose which ones to pull from and which ones to send code to. Initially, you're only going to have master, and we've only really talked about master, but starting a separate branch might be good if you want to test out a new feature, or you want to maybe tinker with something that you're not sure you want to put into the master just yet. So at that point, it could be helpful to create a separate branch or separate version of your code at that point, tinker with that, and then depending on if it fails or you want to add it to the master, you can always merge it back into the master branch. So usually we just have our master branch to start. So in order to put this whole project on GitHub, you go to this node right here and you right click and say create large project remote. And remote means just off of your computer into GitHub. You choose the account, so hopefully you've added your GitHub account through your Xcode preferences. You're gonna give that repository a name, right? So you can see here that this is ultimately the URL where that repo will live. You can give it a description. You can always edit this after. I'm gonna set it to private, right? And then I'm just gonna create it. And then you can see here, there's this pushing. It's pushing the code to GitHub. And then now we can just jump into GitHub. And this is my GitHub account here. So you can see that when I refresh the page, there it is. This little lock represents that it's a private repository. So you can see here, that's the initial commit. I've got a bunch of files here. This is my actual project. This is my tests. And you can see that it mirrors what I have here. Okay, so that's really cool because now whenever we write new code, we can push it to GitHub, and in case our hard drive gets fried, our code is safe on GitHub. Now what I want to do is just run through quickly at a high level unit testing, how to run test cases for your project, and we're not going to really dive deep into testing theory or writing a lot of meaningful tests because the point of this video is to show you the overall process. All right, so you'll notice that we have large project tests here. And if you click into this file here, you'll see that we have this class large project tests. There are a couple of methods here, setup, tear down, and here is a single test case sample. So you can also run performance tests, but in this case, we are not going to do that. I'm just gonna show you how to do simple functional testing to test the functionality and correctness of your code. So let's go ahead and erase this performance test, and we are just going to focus on this test sample. Now what we've got here is we've got one test case, and then we've got our setup and teardown methods. So these two are going to be called before and after every single test case. Now they're basically there just in case you need to write a whole bunch of setup code just to get to the point where you are able to write some code to run your test. And teardown is going to be called after every single test case in case you need to deallocate memory or do any sort of cleanup or put things back in place essentially. So what we're going to do here is write a very, very trivial test case because our app at this point doesn't really do anything, but I still want to show you the process of running, failing, passing tests. So I'm going to just create a simple variable here. Let's say let I equal 0, and then you wouldn't put that there. You would put whatever code you wanted to test. Let's say creating accounts we mentioned earlier. You might test pass in some dummy data into that code that creates accounts, and then you would then want to assert a certain outcome that you expect. So the way we do that is we use xct assert, and there are different methods here. You can check if the outcome is nil, if it's true, if it's false, if it's equal to something. But basically the idea is that you run some code, right, to test something, and you have an expected outcome, and you use this to assert that that is actually the outcome that you got. In our case, I'm gonna write a trivial statement here. We are going to assert that I is equal to 0. And then if it's not, this error message or this message is going to get displayed. So that's going to be the message that gets displayed if that isn't true. Now, how do we run this simple unit test? There are several different ways. You're going to see some diamonds in this line number column. You can run this individual test case by hovering over it and pressing this. So I'm just going to go ahead and do that, and you're going to see something appear down here in the console. So you can see that it executed one test with 0 failures. Then these turn into green check marks. There is also this button here, which you can run. The difference is that hitting this will run all the test cases in this test suite, whereas this one will only run this single test case. Another way is within the test navigator, this tab right here, you can see that you can have your individual test cases here. And then another way is actually to hold your mouse over here, and instead of building and running your project, you would run your tests by itself. So those are a couple of different ways. Now, before we check in our changes into GitHub, let me show you what it's going to look like if the test fails. So let me do that and just change I equals to 1. This is definitely going to fail. So if I run this test case, you're going to see that it's going to build the project. It's going to fail the test right here. So you can see that that statement is not true. So I'm going to change it back to 0. And then now we're going to push our changes to GitHub. So if you go back to the file navigator, I want you to notice one thing. Remember when I said that there was tight integration with Git? Take a look at this. We modified this file by changing some of the code. We got rid of one of the methods. And you can see this M here beside that file. That stands for modified. And that basically tells you what's changed since the last time you pushed your code to GitHub or your local Git repository. So if we wanted to commit this code and push it to GitHub, we would then right-click, go to source control, and say commit large project tests.swift. When you do this, you can fill in a message here to say what you changed, why you changed it, what it was for, and then make sure if you actually want to push it to GitHub, the remote repository, and not just your local repository, you enable this, you choose your branch, you know what we talked about earlier, and we can say added a trivial test case, right? So we can commit that file and push it. So technically, committing is actually a little different from pushing, even though a lot of people use these terms interchangeably. Committing is saying that I'm done with these files and these changes are related to whatever message that you put. Whereas pushing is actually the physical action of putting your code into sending it to the repository. So you can actually do a whole bunch of different commits locally before you push your code to the repository. I know that might not make that much sense for now if you're kind of new to source control, but think of it like a commit is a particular change that you want to make, and pushing is actually sending the code to the repo. All right, so let's go back to our GitHub repository and let's just hit refresh. And you can see here that this was our latest push, right, a minute ago, whereas our initial project push was 21 minutes ago. And if you actually take a look at here, you can see there were 2 commits, right? So this was the initial one for the whole project, and here was our trivial test case edition. And each one has a version number, right? So this source control repository or management system knows exactly when something has changed. If someone else had checked out the code earlier and they try to push their changes, source control is going to say, hey, we're at a new version now, so you better pull down the latest changes and merge them before you push your code over so that our test case doesn't get overwritten. So just to do a quick recap, we've created a brand new Xcode project. We've put it on GitHub. So now actually multiple developers can start working on this project. And this source control management system is going to work beautifully. However, we are counting on each single developer to be diligent in running the test cases. And also they have to write the test cases, right, to ensure that the code they add doesn't break the build and that our app still functionally works. This cannot always be relied upon despite the best intentions of each developer. And so what our next step is going to be is to hook up our GitHub account or this specific repository with CircleCI so that we can get a continuous integration process working. So each time a developer pushes code to the master repo, CircleCI is going to detect that and automatically grab the latest code, build it to make sure that it still builds successfully, run all of our tests to make sure that they all pass. And I'll show you also how to include a lint tool and have that run so that the code can be checked to adhere to the coding conventions of the team. All right, so let's go ahead and do that. So visit the URL on the screen right now or click in the description for the link and you're going to get to the relevant page for building and testing Xcode projects on CircleCI. Start building for free, click on that, and you're going to be able to sign up with your GitHub account. And doing this is going to be good because it's going to automatically give CircleCI access to your GitHub repositories. Now, you can control whether CircleCI has access to your public and private repositories or only your public ones. So on the next screen, you're going to see that. And then once you're signed up and you're into the dashboard, you should see something that looks like this. And you might not have any projects at first, or you might see something here, but go ahead into the Add Projects tab, and you're going to then jump into the Mac OS tab here. Then you're going to be able to start a 2-week free trial, and there's no credit card entry or anything like that, so feel free to give it a try. Click on Start My Free Trial, and then you're going to see your project here. Now I'm going to refresh the page so we can see what I have here. So there we go, that's the large project that we just added to our GitHub account. So go ahead and click on the blue button to set up your project, and this should be automatically detected. If it's not, you can choose macOS and Swift right here. And there is only really one thing that we need to do to set this up and get this going, and that is to set up a configuration file that tells CircleCI what we want to build, what we want to test, what lint tool we want to use, how we want to distribute the build to what environments, and all of that stuff. And so I'm going to show you what that configuration file looks like and a couple of different options for configuring it. So what we're going to be doing now is following this documentation right here on testing iOS applications. Now I'm going to put all of these links in the description below so you don't have to run around looking for these. But let's take a quick look. I'm not going to go through it in very much detail because I'm going to demonstrate it for you. So the basic setup involves making sure that CircleCI can access the Xcode scheme that you want to use. Now, if you're unfamiliar with what a scheme is, let me show you inside Xcode. And actually, this is kind of bothering me, the fact that there are these red X's there. So I'm just going to run the test case and pass it. I really much rather see green check marks. All right, so let's talk about schemes. This right here is a scheme, and if you've never clicked on this before, it's probably because you didn't have to. When you create a new Xcode project, you have a default scheme that is the same name as your project right here. And a scheme, it basically describes which targets you want to build, what tests you want to run, what configuration files and stuff like that do you want to use, because an Xcode project can actually be comprised of many different projects and targets. And a scheme will allow you to specify, which of those projects and targets you want to use and which tests you want to run and so on and so forth. It's basically like a plan. So the only thing we need to make sure is that our default scheme right here, large project, is shared. So click this, go to Manage Schemes, and just make sure that this is checked on, and it should be. So you can go ahead and close that. And I don't know if we pushed our latest test here. I believe we did. Actually, this is probably something we have to do too, is to put this scheme into GitHub, because that is one of the instructions here. After we make sure that our scheme is shared, we have to put it on GitHub so that CircleCI can access it, because CircleCI can only grab what's in the GitHub repository. So once you edit that scheme and make sure that it's shared, go ahead under source control, go to commit. It's going to show you a list of files which have been changed, which haven't been committed and pushed to GitHub yet. And you can see here that there is this data right here. So just let's just push that. We're going to do that, and we're going to commit this file, and we're going to push it. All right. So there is that change right there. All right, so now going back to the documentation, this is what that configuration file looks like. Now, we need to create this file, and we need to put it on GitHub. So let's take a look at what's involved. It looks complicated, but it's really not. I've actually taken this sample and I've simplified it a little bit so that it's a lot easier for me to explain and for you to understand. So what you need to understand is there's this notion of a job. And a job is something that you tell CircleCI to do. Each job has a series of steps. So for example, you can give your job a name like job 1, and then you can specify the steps that CircleCI must do. For example, check out the code and then run some sort of command, maybe run another command, and you would, of course I'm simplifying it here, but you would write down the specific commands that you would want CircleCI to run, and then maybe like save the output of that command somewhere, save the results somewhere. You can also specify what sort of environment or what sort of version of Xcode you want CircleCI to use. And then you could have multiple jobs. You can have a second job to do something else, and that would have its own steps. And then you can have a third job. So this is all listed under jobs. And then you have something called workflows, and workflows allow you to take and pick and choose different jobs that you want to run. So you can have one workflow, and then you can list out which jobs make up that workflow. So for example, maybe this one is testing the project, maybe this one is going to be linting the project or the code, and this one might be to do something else. And then within each workflow that you specify, you can specify, pick and choose different jobs that you want to run to make up that workflow. So for example, workflow 1 that I've specified here is made up of job 1 and 3. So when CircleCI sees this, it's going to run this workflow, and then it's going to run job 1 and 3. So I hope that kind of makes sense. Just to sum it up, you have a series of steps which make up a job, and then you have different jobs that make up a workflow. So if we go back to the sample config file that it has here, now it kind of makes a little more sense, right? So let's go through this sample config file and let me explain it to you. So here's the list of jobs. This job is called build and test. Here is the environment and version of Xcode that we want CircleCI to use. Here we're specifying an output directory. Here are the steps for the build and test job. First, it's going to check out the code from GitHub. Then it's going to run, and for this run command, you can give it a label or a name. It's going to fetch CocoaPod. Then it's going to run this command right here to install CocoaPods and to read the pod file just in case your Xcode project is using any third-party libraries via CocoaPods. Then it's going to go ahead and install all of those third-party libraries. And then here it's going to run a fastlane scan command. And fastlane is another automation tool. If you haven't done a lot of development, you might not have had the need to look into a tool like this. But when projects get bigger and the deployment process gets bigger, you're running tests, you're generating screenshots, and you are deploying it to various environments. It takes a lot of time to go through all of those steps every time there's a code change or a feature completion or something like that, and you need to roll something out. So Fastlane helps you automate a lot of those tedious tasks, and Fastlane works with CircleCI. So that's really great. You can see here some of the features that Fastlane can help you with. All right, so going back to this config file, running a Fastlane scan in this case is basically going to run your scheme, your Xcode scheme. We're going to change this to our scheme that we have, which is large project, and it's going to run all of our unit tests, and it's going to use this device or simulator here. And then it's going to save those results somewhere, and that's the job right there. And here we specify workflows. So this is the build and test workflow, and the jobs that make up this workflow is the build and test job. So I hope that makes sense. What we're going to do now is we're going to take this sample config file, we're going to modify it to our own needs, and then we are going to put it into GitHub. So then we're going to be able to see CircleCI in action. So how do we go about creating this config file? Well, the easiest way, and actually from the set of instructions right here in the getting started, the easiest way to create this config, this YAML file, essentially, is to go to your GitHub repository, click on Create New File, and then we're going to specify the file here. So it's got to live in this hidden folder called CircleCI, and you know it's hidden because there's a dot right in front of it. If you don't have hidden files shown on your local system, then you're not going to be able to see it, but I'll talk about that in a second. So you paste that URL there and it automatically detects that you want to put this file, config.yaml, into this hidden folder CircleCI. And in here, you put the contents of your config file. So we're going to go ahead and we are going to just copy this and we are going to paste it in here. But we're going to have to make some changes. So for example, I want to use 10.2.1. And if you go back into this document right here, it tells you supported Xcode version. So these are all of the different versions of Xcode that you can decide to use. All right, and I'm choosing this version simply because that's the version I'm currently using. I don't need any CocoaPods for our sample project right now. It's pretty simple. We don't have any third-party libraries with CocoaPods, so I'm going to get rid of that. And then it's going to run FastLane scan. iPhone 8 is fine, and our scheme is not web tests. It's actually, if I go manage schemes, our scheme is called large project. So that's what we're going to have to put here, large project. And the rest should be fine. So we're going to go ahead and commit this new file into our GitHub repository. So let's call this creating the config file for CircleCI. Right, and we're going to commit directly to the master branch. Let's go ahead and do that. All right, so now let's go back to our root, and you can see there is a hidden CircleCI folder. Now, if I navigate to my large project folder locally on my desktop, I don't see that file there. I don't see that configuration file I just added to GitHub. So what I've got to do is just go into my Xcode project, and under source control, let's do a pull. So this is going to get the latest changes from our remote repository. So let's go ahead and do a pull. And I'm going to go ahead and pull from the master branch. And if we check our directory now we have that configuration file. And like I said, if you don't have hidden files shown on your computer, then you're not going to see these hidden folders. And there is a way for you to enable and show these hidden folders. Just go ahead and Google show hidden files on Mac OS or whatever version you're using, and you're going to see some simple instructions to enable this. Okay, so now what we can do is we can go back to CircleCI and we can start testing our project. So this part is really exciting. So we've done all of this. We created the CircleCI folder with the config YAML file. We've populated it. We've updated it, pushed this change to GitHub. We've done that. So let's hit this button to start building our project. It's going to grab the latest code from GitHub. And you can see here, this is our workflow. It's running it. And you're just going to have to wait. All right, so it's succeeded. Let's take a look at what's happened. If you click into it, you can see everything that it's done. So go ahead. Oh, here we go. You can see that it's setting up the environment, it's checking up the code, and you can always go into here to see the exact commands it's running and the things that it's doing. Build and run tests. So you can see here it's running FastLane scan, and it's running this scheme here, large project, for our Xcode project right there. There are a whole bunch of different things that you can look at. Now, why don't we do a cool test here? Why don't we go back to jobs, and we can see that succeeded, but let's go back to our Xcode project now and let's break our test. So let's say that let I equals 1, and then I'm going to run this, and obviously it's going to fail, right? But we're going to push this into GitHub and see what happens. So let's save the file. Let's go here. You can see that it's modified. Let's go ahead and commit this. So let's say I was a developer and I was committing some code and, break the unit test. Let's commit and push. All right, you're going to see that CircleCI is going to pick up the change, and then it's going to automatically run, try to build the project and then run the unit tests again. And so that happens automatically. You don't even have to do anything. All right, so CircleCI has finished running our job. Took about a minute and a half, and as expected, it's failed. So let's click into it and see what's happened. So you can see that checking out the code was successful, but building and running tests failed. And you can see, if we just take a look at the output here, that, see, I is supposed to be 0. This test failed. Right, test example failed. And so immediately what's going to happen is I'm going to get an email. Workflow failed. Right, so this latest code change, whoever pushed this into the master repo has essentially broken some tests. They failed. So now someone can go and address it right away, whether that is the person who made the commit or someone else. But the key thing is that we found out about it right now rather than several different commits later, and the issue is buried and hard to figure out. So now let me go ahead and change that back so that it's working. And let me say fixed unit test. All right, and push that. And so CircleCI is going to detect that and it's going to do its thing. Now, while that's happening, let's take a look at linting. So there is a free and awesome lint tool called SwiftLint. And it is a tool to enforce Swift style and conventions loosely based on GitHub's Swift style guide. So it's kind of based on this one, but all of these lint tools are very configurable. And so you can change the rules to what you need and what you like. The cool thing is that you don't really need to do much to lint your code through CircleCI. So let's take a look at how we can modify our config file to include linting. We are going to use this right here. So this is a lint job, which we can copy this configuration for, and we can add this to our configuration file. So why don't we go ahead and copy these steps. We are going to go into our config.yaml file and just click edit, and we're going to change this a little bit. So we've got our build and test job here. I'm going to add a new job. It's basically the code that I took from here, and this is going to be the SwiftLint job. And this is how it looks like. It's going to check out the code and then run SwiftLint and then store the results. But in order to include this job into our workflow, we actually have to modify our workflow here. Build, test, let's say lint, build, and test. Right? So then we add SwiftLint right there. And now let's check out our build here. It's still running. Okay, it should almost be done. Oh, there it is, succeeded. So remember I fixed the test case right here, and it shows you the latest commit, so that's kind of cool. And then now I'm going to commit this. So updated config CircleCI config file to include linting. And just commit that and take a look at what happens here. All right, so it's running. Now here's the workflow, lint, build, and test, and here is the job. This one is testing the build and test job, and this one is running the SwiftLint job. So it's gonna run, and let's give it a little bit of time and see what happens. All right, so our new workflow has finished, and the linting took about 22 seconds, and building and testing took about a minute and a half, same as before. Now, this has succeeded as expected, but our linting has failed. So let's take a look at that. We're going to click into it, and we are going to take a look at SwiftLint reporting on all of these violations. You can see here, done linting, found 15 violations, 3 serious in 3 files. Now, the only files we have essentially are in terms of Swift code, right? App delegate, view controller, and large project tests.swift. So let's take a look at what SwiftLint has to say about that. Here, failure message. Files should have a single trailing new line. And it tells you that this is in view controller.swift. It also tells you that inside view controller.swift, limit vertical white space to a single empty line. So I'm not going to go through all of these and fix all of these for you now, but I do want to fix a couple ones and show you what that looks like. So files should have a single trailing new line. If you take a look at here, it's basically saying that I have 2 new lines after it, and I should have 1. So, you know, it can get pretty detailed. Again, in appdelegate.swift, I have 2 trailing new lines at the end, and it should only be 1. And oddly enough, large project tests.swift only has 1. So now everything's consistent, right? Other rules include that lines should be 120 characters or less. You know, this is saying that some of this code is going way too much into the right. And so if people were to read it, they'd have to scroll left and right too much, right? So there are some rules that say that your code should be written in a way or spaced in a way so that it's not too wide. So all of these rules are really configurable, but at the end of the day, it's going to help you maintain a very tidy and consistent code base. So we've just made 2 changes, right? So let's commit these 2 changes, let's push to remote, fixing new trailing new line violations. How about some new line lint violations? Commit these 2 files and push. Now here's a very interesting thing I want to tell you about. So we've just we fixed 2 violations, right? So we should see this go from 15 to 13 the next time we do this. But if I go into jobs, you can see that CircleCI hasn't triggered. So why is that? Well, if we go back to GitHub and we refresh the page and we look at our number of commits, we don't have the latest commit that we did. My message was fixed trailing new line lint violations, right? I committed that, but where did that go, right? The problem is that we changed our master repo from this web-based interface, and so it's out of sync with our local copy right here. So that's why I wasn't able to push those code changes into GitHub. Instead, what I have to do is first pull any changes, right? Pull them. Basically, they were changes to the config YAML file. So now that I have all of the latest changes, I need to merge any conflicts, but there weren't any. So now, actually, I can go and push the code. I can push my last commit. So now it will actually succeed. So if I refresh the page now, you can see here that this contains my latest change. Fixed trailing new line lint violations. And now CircleCI will pick up that new commit, and it's going to run the lint test again, and it's going to build my project and run the unit tests as well. All right, so CircleCI has finished linting our code and also building and testing our project. So building and testing our project has succeeded as expected, but SwiftLint has still failed. And that's because we didn't fix all of the errors or violations, right? If we go down here, now it's only found 13 instead of 15 because we fixed 2 of them, right? So we're still in violation, but I just wanted to show you that as an example. So here we also get emails to notify us that SwiftLint has failed. Someone has checked in some code that has violations, and so you should go and address that right away. So as you can see, all of these tools help teams collaborate and work together efficiently. And once you set it up, it just works for you and you can focus on writing your code. Now, there are two very important things I want to mention. And number one is that these tools and processes are very common in the industry. So if you have experience with them or you build the skills in using them, it's going to give you a huge leg up in getting hired as an iOS developer if that's your goal. And number two, I've spoken about these tools in the context of large teams working together, but I hope you can see how these things can even help a single indie developer building his or her app. By offloading a lot of the tedious tasks and also automating the testing side of things, it's going to allow that developer to save time, the precious 24 hours that he or she has, and just focus on writing code. Now in the future, I want to dive deeper into some of the topics that we had to gloss over, such as configuring SwiftLint, unit testing, using Fastlane. If that's something that you want to see, please drop me a comment below and let me know. That's going to give me a huge vote of confidence to move forward on these topics. And finally, I want to thank CircleCI so much for creating such a great product for developers to create awesome apps, and also for sponsoring me and allowing me to create high quality and free tutorials for you guys. So to start making continuous integration and delivery a part of your development process, click the link below and sign up for a free account.